Hello. Now we are going to discuss how to find the potential evidence for effective Android forensics. In this regard, we can start with the study of identifying and managing potential evidence for effective Android forensics. My group members include Adil Ahmed Zirak, Naveed Naeem Abbas and myself. We have chosen this research article from Science Direct and now going to demonstrate multiple aspects of this in the upcoming slides. Let's start with the introduction. As we are well aware that Android devices are nowadays the basic need of the society, there are many applications on the Play Store which are used by individuals for their personal benefits, but installation of multiple diverse applications produces a very large amount of data. The unknown applications are sometimes cause harm to individuals by establishing a remote session to different devices, etc. Basically, the scope of this research article is to describe the series of data classification, analysis, and abstraction studies aimed at identifying and effectively managing potential evidence. Now, let's see what kind of problems the unknown application cause to forensic investigators. So, the vast amount of application data makes it difficult for the investigators to identify when analyzing unknown application. It is difficult to update the forensic tools to analyze the application immediately. Even the tools like Oxygen, UFED, XAMN are not able to analyze all the published tabs. The proposed methodology includes three steps. First of all, by analyzing the logs. Now, first thing to get done is categorize the potential evidence into groups. Data grouping is based on application labels. The main hierarchy is taking Android raw data logs, then see every file of applications and then categorizing them into group and then marking the label potential evidence. Next phase is identification of potential evidence. The file format classification is based on signature. Next thing is identification of the application logs. Last thing is management of potential evidence and Android data taxonomy. It includes management of potential evidence. Basically, the team has created a format just like the digital forensics XML, which we call DFXML. The members has designed Android forensic XML format to view the categorized potential evidence into this format. The tool and forensics is developed. The tool and forensics, basically it is the tool, it is named as and forensics, AND FORENSICS, and forensics is a tool name which is developed by the authors of research article. Basic flow includes the raw data from the Android, you can say the raw data from the Android device, from the, you can say, application logs or anything, and then identifying the main groups for the potential evidence or which can act as a potential evidence. Next, file classification is done on the basis of group. So what we call group is basically the classification from raw data log into some basic categorizations, and the results are then sent to identify the potential evidence. And at the end, all things categorized into AFXML format, as I have told you in my previous slide that AFXML format is used to show the data from unknown applications. So this means that it is the main hierarchy. Now we will see the results of this algorithm number 3, which is demonstrated in this slide. You can see, like I have already explained, the input and the result. The first of all input is data grouping, and next is PEG, identify the groups, and then after identifying, the file classification is done. After file classification, the identify user information is done, and then we go to the create potential evidence, and then at the end the all information is clearly seen in the AFXML format. So that's the main hierarchy. And on the right side of this, then a clear algorithm is seen, right? Now moving towards the results. With the previously described algorithm, the unknown applications can also be analyzed. This is the main result. This is the thing that the team has achieved. Now the next thing is that the new evidence format helps in improving the efficiency of analysis and maintaining the integrity of evidences by the Merkle tree and hashing algorithm. Basically this means that to maintain the integrity of the evidence, that it is not altered, it is from authentic source, it is not, you can say, manipulated, or it is not tampered. So to maintain the hashes, we use the Merkle tree and the hashing algorithm. Now this could be used very efficiently in real world forensic investigation, and any researcher which tries to see the data of Android applications that are basically unknown can use the AFXML format to achieve this. Next thing is that we will see the future work. The future work include the counter anti-forensics such as data encryption and complete deletion and study of data analysis from various perspectives such as user relationship analysis and local analysis. You can say first thing is to explore the more effective analysis of user behavior. Second thing is counter anti-forensics such as data encryption and complete deletion, and last thing is that study the data analysis from various perspectives such as the user relationship analysis and location analysis. So this was all from our side. Thank you very much for listening to us, and please leave a comment down the section if you have any questions regarding this. Thank you very much. Allah Hafiz.